welcome back to my Project Euler series in Python. Today we'll be solving problem 2. So, even Fibonacci numbers. Each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. Okay, so that's quite a mouthful. Let's break this down. So we want to know about the Fibonacci sequence, and the next term is generated by adding the sum of the previous two terms. So 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and that's just how it works. But I think they say by starting with 1 and 2, I'm going to try and go back one step. So the 0th element, for example, would also be 1, because then 1 plus 1 would get us to the 2. So yes, the first term is 1, but also the 0th term could be 1. So then we can use that as like a starting point to generate the rest of the sequence. So let's have a go at that. Here we've got the problem 2 file. Get rid of the hello world. If we do for I in range 10, because we want the first 10. Let's say, so before we start the sequence, let's say the previous value, i.e. the 0th value, is equal to 1, and the current value in our sequence is equal to 1. So this is our first value. So let's print current, and then the next value is created by adding the current value and the previous value. So that should give us the next value. So now let's think. So that should print out the current, generate next, which would be 2, based on the current values of previous and current. And so then that would go through, but it would just print 1 again. So we need to also shift the values down so that they can make way for the next values in the next iteration to keep regenerating a sequence. So the previous value would actually become the current value, and the current value would become the next value. And then we print that current value, and we've already stored the next value in current, so that the actual next value for that iteration is ready to be overwritten. So hopefully that prints out the first 10 terms. 1, 2, 3, 4. Okay, yep, that seems to match our sequence here. Okay, so now we know how the sequence works. Let's see the problem. So by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. Okay, so let's see. We might have to restructure this a little bit, because instead of just going for the first 10 terms, we now want all of the terms that are under 4 million. And we don't really know exactly how many that's going to be. So we're going to have to rip out this for loop and replace it with a while. So while the current value is less than 4 million, we can sort of do the same thing. Print the current value and carry on your way. Keep regenerating the terms. Let me restart the sequence as well. Here we go. So yeah, we don't need that first bit. Let's just keep it in for now on problem 2. Well, okay, relatively fast. So that gives us the Fibonacci sequence. You can see we've run out of those terms quite quickly. So now I've got all the terms under 4 million. Find the sum of the even valued terms. Okay. So instead of printing it, let's do an if. So like in problem 1, we want if the current value is divisible by 2, which is basically the same as saying if you divide it by 2 and get the remainder, is the remainder 0? And if it is, then we care about it. We want to add it to the total. So plus equals the current value. And we need to obviously instantiate this total variable, set that to 0. And then we can print the total once we've calculated it. Boom. So that is 4,613,732, and let's sign in. Spoilers, I have done this problem before. It's been a while, but I believe that is right. Yeah, sweet. Okay, so let's take away the original code because you don't need that anymore. All right, nice. I'm going to try and keep the code running relatively quickly. So yeah, this runs quite nicely. I'm going to also try and keep my code relatively neat. This is fine for now. So I'm going to leave this problem here, but in future problems, once I get the right answer, I might see if I can find any optimizations or code cleanup. But I'm pretty happy with this for now. Let me know if there's any improvements I can make in the comments, and I'll see you next time.